Okay, so who has the answer for A? What do you think? Go ahead, Anna. Is it exponential? So this is adding by 1. What did you decide was happening at the bottom of this? It's adding by 2, which makes it, that's right, it's linear. If it had been multiplying or dividing by something at the bottom, it would have been exponential. So the first one's linear. How many of you got that? Good. Okay. Who knows the answer to the next one? Cameron, go ahead. Why? That's right. X is in the exponent. This right here gives it away. X in the exponent makes that exponential. Boom. All right, let's go. Let's go do a story problem. So I know we don't normally, that's normally not our favorite, but these are actually nice story problems, okay? So suppose this is actually true. In a lot of food, that there can be a certain number of bugs in it, and it's still considered safe by OSHA, okay? So, but if it exceeds that number of bugs, then it's not safe and you can't eat it. Okay, so suppose 30, now that we know that, it is what it is. Suppose 30 flour beetles are left undisturbed in a warehouse bin. So there's flour in a warehouse, right? Big amounts of flour. And there's 30 beetles in that flour that you're going to use to make your bread with, okay? The beetle population, all right, bugs multiply usually quickly, don't they? Doubles each week, okay? The function f of x equals 30 times 2 to the x power gives the population after x weeks of that flour sitting in the warehouse. How many beetles will be there after 56 days if that flour is undisturbed, if you don't move it out, if you don't sell it? All right. What do you think? 56. What are we going to do with 56, first of all? What's going to happen? Go ahead, David.
You're going to put it as x?
Close. And eventually we're going to use it in our equation. However, think about there's something that you're missing here. What is it, Carla? Why do we divide it by 7? It is per week, okay? So 56 divided by 7 gives me what? 8. So we're really working with 8 weeks, aren't we? So now what do? We put 8 in for x, okay? So we're saying the function of x, right? Or actually, I should write it like this. The function of 8 weeks is equal to 30 times 2 to the 8th power. So this is the part we put in our calculator, right? The other one is just saying like the function of 8 weeks, right? If this happens, what did you get? How many beetles are going to end up being in that flour bin? Go ahead, Speciosa. Sweet. 7,680 beetles. If they don't go in and do something, move that flour out or exterminate it, 7,680 beetles in the flour. Crunchy. Nice. All right, that's how you do kind of a story problem here. All right, the one thing I want you to be aware of is this first part. If it's measured in weeks, but they give it to you in days, you've got to convert that first before putting that in. All right. Last part is using your calculator. Okay. So graphing calculator, or you can do it by hand. If you do it by hand, you can do the table out by hand first and then graph it, okay? But I'm going to show you the shortcut. So it says, what is the graph of 3 times 2 to the x power? So what you want to do is put that in your y equals, okay? 3 times 2. How do you put to the x power in it? What do you do? Yeah, caret x. Like that. And then what I recommend before you look at the graph, look at the table, all right? Because a lot of times when you have to make your own graph, you're really looking at just the first few values, right? So go to second graph to the table. Oops. right? And let's list the first few values. So x value and y value. If x is 0, y is 3, right? If x is 1, y is 6. If x is 2, y is 12. If x is 3, y is 24. And if x is 4, y is 48. Usually that's plenty of values. Now, and you want to be accurate. So sometimes you can just sketch a graph, right? And you can just go to graph like this, and you can just kind of sketch that, right? And do that. But a lot of times they want you to be more accurate. So what you want to do is you want to make a graph, right? And this is if this is my x and this is my x is only going by 1. So I'm going to make this by 1s, right? Making 4 or 5 spaces in there. What do I need my y values to probably go by for this scale? At least 3s, 4s, even like if you only have a limited amount of space, you could even go by 5s or 10s, right? So I'm going to go by 10s here. And I'm just going to show you that the reason we want to kind of do that is you're going to scale, and it's trying to show that this is increasing fairly rapidly. So 0, 3, yeah, we're going to estimate that that's right here about. And then 1, 6, again, it's not going up by very much at first. So that's going to be really close. 2, 12, again, still not very much. 324. Now we're getting somewhere a little bit. 448. Okay. And then you want to connect them because it's a continuous graph. And it's going to continue like that. And it's also going to continue this way, like that. And that is the most accurate graph, right? This would be just a sketch. So this is what I want you to get used to not doing, because some of you are doing this a lot. This is an accurate sketch of a graph. This is an inaccurate sketch. For you to do this, right? And then just do this. That is not going to get you any points on a test. This is. Okay? Be more accurate by using your table to make sure. All right, that's awesome. Sweet. Got the lawnmower in the background today. All right, one more thing. Anthony, will you shut that a second? Not that helps. All right. Last thing, again, we're going to use our graphing calculator for the video that you can't see it very well. This says, what is the solution or solutions of 2 to the x power equals 0.5x plus 2? Okay, this is really trying to figure out where these are equivalent. And so the way you do that is you graph them and see where they cross. All right, so let's do that. So take your graphing calculator out. Go to your y equals, and we're going to put them in separately. So you want to put these in as separate graphs. So let's maybe write that in our notes so that we remember. All right. So we're going to put these in as separate graphs. I'm going to first put in 2 to the x power for y1. And then for y2, I'm going to put in 0.5x plus 2. And then I'm going to hit graph. So the first one is an exponential function. The second one is a linear function. How many places do they cross? Nope. 2. All right. They cross here, down here, and they cross up here. Okay. And so we have 2 answers to this. This is how we do it now. We're going to go to stat. Oh, not stat. I'm sorry. Math. I forget now. Second. Nope, stat. I think stat, intersect. We got to go to intersect. Where is it? Nope. Okay, nope. Second, calculate. There's too many. There we go. Second, calculate. Second, trace. So let's write this in so that we don't.
What?
Second trace, which above trace, notice there's a blue calc sign. Okay? And that is going to get us, we want to see where they intersect. So number 5 says intersect. So you can either press 5 or scroll to 5, okay? And it'll go back to the graph. And then they're going to call both of these curves. So there's 2 spots, all right? So the first thing you want to do is get closest to the first intersection. So I'm going to arrow this over so I'm close to that first intersection. Press enter for first curve. Then it should jump up to the other one, right? See, it jumped up to the other line. Second curve, yep. And now it says guess. So press enter. And it will give us the first intersection. So our first intersection are the solutions. So the first one is x is negative 3.8 about 625. That ends, comma. And we're going to have to round this one. 0.0687. All right, so that's our first solution. Is this, all right? Now we're going to do it again for our second solution, but we got to use our arrows to get close to where the second intersection is, okay? So let's do that again. So we're going to press second trace, 5 again. Now notice it left off where we left. So we're way over here. Your blinker is, your cursor. So arrow it over so you're close to the second one now. Then press enter, and then it'll jump up to the other one again, but in the second spot. Press enter again, and guess. Yep, we want it to guess, and it will do the second one. So our second intersection is about, and we're going to have to round again, 1.445, comma, 2.722. And this is our second solution. And there you go. That's how you do it. Oh my gosh, this cord is so bad. Okay, that's it for lesson today. Long lesson. Sorry about that.